Hi, welcome to this tutorial. This is Teacher Raya from Elibu Hubs Math, and thank you for visiting. Hope you like my tie today. It's a hint because we're going to use the pie at some point in our session. So the reason for this session is to show you how to find the formula for calculating distance between 2 points on the same latitude. And the reason for doing this is because a lot of us are just using the formula, but we don't know where it came from, and that causes challenges in understanding this topic. So hopefully I'll help you get this all good for you in your head. All right. There will be quite a few sessions on this particular topic, the Earth as a sphere. So please, if you haven't subscribed, press the button on your bottom right now and let's start. So I was referring to this formula where you find distance between 2 points on the same latitude, and then you may wonder, oh, I don't really understand what is alpha, which one is alpha, which one is theta, where did this r called theta come from, where does 360 come from? Okay, I'm going to explain it all to you now. Okay, we have a sphere here, so we're going to say this is our Earth, and then we have the equator, which is 0 degrees, we have the radius of the Earth, which is r, and then we have this latitude, which we can say is theta degrees north. Okay, so you will have lots of latitudes here, but we're just going to use one example. So what does this mean, theta degrees? That's the angle between the equator, okay, and where this latitude is. You have to think about it. It's on the globe and it's on the corner, so P is on the corner of the globe. That whole latitude is at theta degrees north. Okay, so this angle here is what is referred as theta degrees. What else is what else do we need to know? Well, we need to know the radius of the small circle, so that's our latitude, and the center of this small circle is exactly vertically to the center of the equator, so we have 90 degrees here. Okay, so this is also the radius of the Earth, the OP. And now I'm going to show you something. So if we draw this shape here, which looks like Z. Okay. Now this is from there to there is the radius of this latitude, the small circle. This here is the radius of the Earth, the great circle. These two are parallel to each other. Now, if we know about angles in a parallel line, so I'm going to take that Z out here. This is our Z. Okay, so what we have here, we have O, Q, and then we have a P here. This is theta, and the radius of the Earth goes on that way. This is the radius of the Earth, and this is the radius of the small circle. Now, what about this angle? What is the size of this angle? So according to angles in parallel line, this is also theta, because these two are parallel. So alternate angles are equal. If you remember, alternate angles are like that. So that one and that one. We nickname Z angles because you have like a Z. Okay, so that's theta. Now, if you want to find the radius of the circle in terms of the angle theta and the radius of the Earth, you need to take the cosine of theta. So cos theta then is going to be equal adjacent over the hypotenuse. So RS over R. So this means the radius of the small circle is equal to R cos theta. So that is where that bit comes from. Now let's do the next part. Okay, so if I take the this small circle here, the green one, and draw it over here as 2D. It has a center and it has RS. And then we have 2 points. One is N and then the other point M. So I'm talking about these 2 points. And this is also the radius of the small circle. And these two, the angle between them, that is called alpha. Could be anything. So it's just between the longitude. The angles between the longitudes is alpha. Now we want to find the distance between M and N. So distance between 2 points. What do we have here? We have the length of the arc. And what is the length of the arc? An arc is a part of the circumference. So if we take the proportion of it, then we can find out what the length of the arc is, and that is the distance between 2 points. So the length of the arc, which we're going to say D, is equal to the proportion of the circle that it occupies, which is going to be alpha over 360 degrees, because a full circle is 360 degrees, times the whole circumference. Okay, so 2 pi r of the small circle, because we're dealing with a small circle. And now we know what the small circle, the radius of the small circle is. We're just going to substitute that in terms of r cos theta. So our distance between 2 points is equal to alpha divided by 360 degrees times 2 pi, and now instead of that I'm going to write r cos theta. Okay, so that is how that formula was derived. I hope this will help you in calculating these type of questions. In my next session, I'll be doing a couple of exam style questions in this particular area. Okay, but again, thank you for watching and see you again. Bye for now.